use case, trying to illustrate where you might use a blockchain. It is a contrived example because I don't have a practical one other than Bitcoin that I can go to and say, here it's being used. We're sort of at the stage with the technology that people are looking into starting pilots. So I came up with this case where you've got a company that makes heavy mining equipment or some kind of machinery anyway. You have a head office where they design this stuff and handle the finances, and you have a factory where they build them, and there we have these lovely machines rolling off the assembly line. The equipment is shipped to various locations, and because it's big, heavy machinery, it's got to comply with safety rules and legislation. It's not like a moped where you can just ride off and do what you like with it. And it's got to be serviced by approved maintenance companies, and they have to use certified service engineers and approved parts. You don't want your airplanes being serviced by some local 2-bit garage using spare bits that they scavenged. So that's kind of the case here. And then the final thing is the equipment may actually be sold on from company to company, and eventually it has to be decommissioned and broken down and disposed of. So there's a whole load of legislation that would apply to this case. And with a traditional database system, you have some problems in that you could have denial of service attack on the database, which means that you can't get to the records anymore for a while. And this has actually happened. The Port of Rotterdam had a problem with their stuff being tampered with for a while. The records can be changed, so if the company produced some defective parts, they could go in later and delete the fact that that happened. And unless there were external auditors coming in regularly, you would never know that they'd had a problem. And for some industries, that would be a serious issue, and it'd be a serious breach of trust. And we have cases in history where big companies have covered up bad behavior. Then there's the fact that typical large companies, they may be running 10, 15, 20 different database systems, and they don't interoperate, and the data has to be copied across. There's a lot of manual processes, and things get triggered, like, oh, now we have to do this, now we have to do that. There's some person who actually has to remember that something has to happen. Hopefully they've put it in their Google Calendar, so they do it on time. And then finally, you have this situation where B, C, and D, the servicing companies, are they're separate entities. They have their own business to run. It's in line with A, but it may not always be so. So you want to be able to give them permission to join in and then later remove it and not have that be an IT infrastructure headache. And if anything goes wrong in this system, you end up with legal action in order to get redress, and that can be expensive and take a long time and may never even fully be satisfied. So that's the use case setup. And now I have a slide with far too much text. To summarize it, you've got a distributed blockchain so that the different parties working together can each run their own peers to add blocks, so they all know that they're working together to create the database. They all know the database is tamper-proof, so no one entity can go in and change it. And then finally, something I'll be talking about later, there are these things called smart contracts, they're basically snippets of code that can be put onto the blockchain, and then they get run and they trigger events later that cause other actions to occur. So we'll start off with the beginning. The company that makes the equipment starts the blockchain and publishes block 1, which is called a Genesis block. And they actually announce themselves on it. They have a public key that they put there saying, this is us. And the blockchain ticks away, blocks get added at a regular basis, and the blockchain grows. Then you've got some other entities who join, the factory, which is actually part of A, and maybe one of the service providers. And they publish their keys, and now they can join in as well. They're running nodes, they have their own keys, so they can identify themselves on the network and on the blockchain. And one thing to note here is that it uses public key infrastructure technology. So when B publishes something on the blockchain, A knows that it was B and not somebody else, because B has their own private key. They're the only ones who can sign records that can be verified with their public key. So now we have A, manufacturing some components to build this wonderful yellow machine. Every time it creates a component, it can create a key pair for it and announce the public key on the blockchain. And that then gives you a timestamp when the component was created. It could also log the location, what equipment it was. And the whole lot gets assembled into one machine, which then gets its own key as well. So this is where you're starting to record the data that you're generating and making these machines on the blockchain. How would you handle these keys? Well, for cheap components, you might just have a QR code of the public key for scanning, and you keep the private key back at the company head office. And actually, you don't really care about signing things. It's just a way of saying this is a unique component. More expensive parts, you might use an active RFID tag or a small IoT device. And they would actually then be able to sign challenges. You'd be able to send a request to a component saying, are you this part? And it would sign it with its private key saying, yes, I am. And that would verify that it was a genuine component. And when you put the whole thing together, you may actually have a fairly powerful Internet of Things device on it. It may actually have an RFID scanner, so it can scan itself and say, right, I have all these components in me. This is what constitutes me. It may have network connectivity and positioning technology, so it can actually say, I am here. It could regularly report its location to the blockchain. So you're sort of starting to see how the blockchain is kind of keeping a record of the progress of this equipment. So moving on to the smart contracts. So when a component's created, you could put a smart contract on the blockchain at the same time, which is a bit of code that the peers can periodically run to see if a condition that that code is looking for is met. So here I've written a bit of pseudocode that it's looking at, is this component too old or has it worn out? And if it is, it triggers a service request. And here's an example of that happening. You've added the component onto the blockchain with a smart contract saying when it needs to be replaced. At a certain point further along the line, that the condition of that code is triggered. So a blockchain node would then send off notification to the service company saying this component needs to be serviced or replaced. And then the engineer goes out. He has his own, or she or he has his own identification. That's their certification keys, that they're proving they're a certified engineer. They bring a new component, and they service the component, and they report that to the blockchain, and the contract is met. And this has all happened in an automated manner, rather than needing to have logbooks. Like when you take your car to the garage and you have it serviced, and they have to stamp the back of the book, and after 5 years you don't bother doing it anymore. This automates it, you don't have to worry about that. We have another case here where the service company says, right, actually that engineer is no longer a certified engineer. Maybe they quit, or maybe they were fired and weren't competent enough, and the company can cancel their key. But all the records that were made with the key beforehand are still there, so you can still see the service history, and it allows you to go back and say, right, actually, service engineer B555 did this work, and then they were prevented from doing any future work. And A can go and have a look at that. All right. Okay. And then the final case, earlier I talked about transferring the ownership, so you can record that on the blockchain. You actually say, right, X owned it. It can now sign a transfer agreement to Y, saying that Y owns it, and it can report the location, saying, and we have actually shipped it to Y's facility. And that's all on the blockchain, and then later Y can't turn around and say, well, we never got it, because you can say, well, you know, you signed it, I signed it, and there's proof that it was in your front yard. So if you haven't got it anymore, it's not our problem. And similarly about decommissioning it, you can say, right, Y goes in, maybe the original manufacturer goes and signs it as well and says, right, this machine has now been destroyed. That means you can audit the application of, for example, environmental legislation later on, saying, yes, they did the right thing. And so in summary, there's the blockchain along the bottom, and there's all the key events showing that all these things actually happened. and anybody who's got access to the blockchain, if it's a permissioned one or if it's a public one, anybody can go in and actually see, yes, everything was done properly.